Question number 11, we are given a resistor of resistance 100 ohm is connected to an AC source with E equal to 12 volt sine 250 pi per second into T. Find the energy dissipated as heat during time T equal to 0 to T equal to 1.0 millisecond. So the voltage is varying across the resistor. So the instantaneous power will also vary with time, and we can find the instantaneous power in this resistor using the same formula. P is equal to V square by R. So let's do that. Number 11. P, if this is instantaneous power, it depends upon the time. So P, I'm writing as a function of time, is equal to let's call it V naught square sine omega t divided by R, where V naught is 12 volt and omega is 250 pi per second. This is the unit. Now with this, when we know the power, then we can find the energy dissipated as heat in a small time. Let's call it du as pt into dt. This is the formula for the simple formula for the energy dissipated. Power is the energy dissipated per unit time multiplied by that small time dt. You get the power in that time, energy dissipated in that time. And if you want to find the energy dissipated from t equal to 0 to, let us say, t equal to tau, you can integrate this whole thing from t equal to 0 to t equal to tau, and this thing will becomes integral of V naught square sine is okay. So P sine, this is we missed the V square here. When we write P is equal to V square by R and V is equal to V naught sine omega t, so the V naught square sine square omega t divided by R dt. Now to integrate this from 0 to tau, sine square theta can be written as, we use the formula 2 sine theta. Okay, 2 sine square theta is equal to 1 minus cos 2 theta. And then if you substitute this thing here, so to make it 2, or you can write sine square theta is equal to 1 minus cos 2 theta divided by 2. So this becomes, we bring V naught and R stays constant, so V naught square divided by 2R integral of 1 minus cos 2 omega t divided by 2, or 2 I have already taken out, so this is not there, dt. And we can integrate this with that V naught square by 2R. 1 has an integral of t, cosine theta has an integral of sine 2 omega t, and then divided by this factor 2 omega t equal to 0, and we need to find it from t equal to tau, where tau is 1 millisecond, from t equal to 0 to t equal to 1 millisecond. Now let's substitute these values. V naught square is 12 into 12 divided by 2 into R. So 2 into R is given as 100 ohm. We will write 100 here, and t equal to 1 millisecond, so 1 upon 1000 minus t equal to 0 will be 0, so we will not write it here. And then when we write t equal to 1 millisecond, we will write sine 2. Now let's put the value of omega. Omega is 250 pi. 2 into 250 pi into tau is given as 1 millisecond, so 1 upon 1000. This whole thing divided by 2 pi, 2 omega. 2 omega is 250 into pi. All we need to now do is just simplify this whole thing. So this becomes 672 divided by 100 is 0.72. 1 upon 1000 minus 500 divided by 1000 divided by 500 is 2, so this becomes sine pi by 2 divided by 500 pi. This becomes 0.72. Sine pi by 2 is 1, so 1 upon 1000 minus, I will write it as 2 by 1000 pi. We can take out 1000 outside, so 0.72 divided by 1000 multiplied by 1 minus 2 by pi. You can write it as 0.72 divided by 1000 pi minus 2 divided by pi. You will simplify and find out the answer. I will leave it to you as an exercise.